In the last lesson, we created a ROS publisher in C++. So now how do we go about executing this code? Well, as C++ developers know, you need to compile or build your code into an executable first before being able to run it. In ROS2, the default C++ build system is called ament CMake, and we will use it with ROS's Colkin command line interface. The core instructions of building our project are found in our package's cmakelist.txt file. Let's take a look at the cmakelist.txt file in our Udemy ROS2 package. This file was auto-generated when you ran the cat create package command, and is populated with comments to help remind you of common functions you can use. The four main CMake functions we will use throughout the course are find package, add dependencies, add executable, and install. You can put these functions pretty much anywhere in the file as long as it's not below this ament package call at the bottom. I'll just put them here between the find dependencies comment and our build testing instructions. Since we want to be able to run our publisher node, we will have to add an executable, and we will just call it publisher. You can call this anything you want. This will just be the name of the executable. Then we will reference the file, which is in the source folder and called publisher.cpp. Now let's add target dependencies that our publisher.cpp file references. So ament CMake is aware of it. So if we head back to our publisher C++ file in the editor, we see we included the C++ version of the ROS client library and this standard messages package, which we got our string message type from. So we need to add these target dependencies so the compiler is aware of them. So you just separate them with spaces. Don't put any periods or anything like that. You could also put them on different lines, but as you will see later on in the course, this will get kind of messy. So for now, just list all your dependencies on a single line separated by spaces after the executable name. Now, since we included these new dependencies, we need to make sure we tell CMake to find these ROS packages. So I can just copy this find package call and paste it twice, one including the RCL-CPP and one including the standard messages package. And I'll go ahead and delete these comments for right now. Last but not least, we need to configure an installation target for our nodes so that our ROS2 command line interface tool we'll be using can find these executables. So I will add our publisher executable and set the destination to the lib directory, followed by the project name variable, which references our package name as declared above here. Which brings me to another point. If you ever want to change the name of your package, you will need to change the folder name as well as this declaration in the CMake file, and the package.xml file, which we will go over next. With that, we have set up everything we need within the CMake file so that our publisher C++ file gets compiled with the proper dependencies, and we redirected the executable location. If you ever want more details on what all of these calls are doing, you can reference the ROS2 documentation page on ament CMake. But for now, I will just go ahead and save this file with Ctrl+S. And with that, let's head over to the package.xml file. The last thing we need to do is declare any dependencies for our ROS package so that anyone else using it can use ROS-dep to make sure they have the proper ROS dependency packages installed. So we will just include our ROS client library and standard messages dependencies. Great, with that we are ready to compile our publisher node. For now, I'll go ahead and be sure to save this package.xml file, so I'll hit Ctrl+S. Alright, so I've gone ahead and saved my package.xml file. I'll go ahead and minimize the VS Code window. I will open up a new terminal, and I'll change into our workspace directory. Now, assuming you have your ROS2 installation source to your terminal, you should be able to use the colkin build command. So here we see it starts to compile our package. So I can go ahead and open up our file explorer, and I will head over to our workspace directory. And so we have our build, install, and log directories, which were generated when we ran colkin build. And I can go into my build folder, go into the package name, and here we actually see the executable for our publisher, as well as all the files related to building it. Now, we won't be running the executable from here because we will instead use the ROS2 run command, which instead looks from the installation directory target we specified in our cmakelist.txt file. So we go into install, our package name, lib, our package name again, and here we see that same publisher executable. This is a directory ROS will use to find all of our package executables without needing to worry about all the other build files. Now, there's another important file you need to know about in this install directory, which is the setup.bash file. So I'll go ahead back to install, this setup.bash file right here. This file will allow us to source our terminal so it is aware of the location of our package. We can see this in action if I go back to my terminal and use ROS2 package list. So our package name is Udemy ROS2 package, so it should be listed near the bottom here, but we don't see it. So now if I use the source command followed by the location of the setup.bash file, so source install setup.bash. So now our terminal is sourced to our workspace, so any packages we built in this workspace can now be recognized by our terminal commands. So let's rerun the ROS2 package list command one more time. And here we see our Udemy ROS2 package listed, which means we can do things such as run our newly compiled publisher node using the ROS2 run command, which takes in the name of our package, followed by the name of the executable, which in this case is publisher. You can even use tab completion here to finish the lines for you. Okay, we run the command, but nothing seems to happen. Well, that's because our hello world messages are being broadcasted over ROS, not via the standard output to the terminal. So what I can do here is open up a second terminal, and I can use the ROS2 node list command. And here we see the name of our node, which we specified in our code, which is hello world pub node. So if I open up my VS Code window, it's the same name we specified here when initializing our node. Then we can check for what topics are available over ROS using the ROS2 topic list command. So here we see our hello world topic we specified when we created our publisher. We also see that there are two other topics named parameter events and ROS out. These are standard topics which get published to by nodes to the ROS2 daemon. Now let's finally get to retrieving this information from our publisher, which we can do with the ROS2 topic echo command, which takes in the topic name, which in this case is hello world. Here we see the message hello world followed by a number printing to our screen once every second. If you want to stop these command programs from running, you can click on the respective terminal and hit Ctrl+C on your keyboard. You can go ahead and actually restart this program by heading up. And you see it starts printing our hello world messages again. And if I go to the top terminal and hit Ctrl+C one more time, we see it stops our publisher and we stop receiving our messages. So I'll go ahead and hit Ctrl+C on this terminal as well. I'll actually go ahead and rerun both of these. So I'll go ahead and rerun my publisher node one more time. And so another thing I want to show you here while I have this running is if I go over to my VS Code and I hit F1 to open the command bar, and if I type in ROS, we see some of the commands from our ROS extension show up. So I can go ahead and type in show status. So if I go ahead and click on that command, we have this little window on the right hand side, and I can actually go ahead and minimize our file tree so we can actually see a bit better. And so here it does things such as list out available nodes, list out our topics, which we also did in terminal, as well as other things such as services, which we will talk about later in the course. So now if I head back to terminal and I stop our publisher node, we can go back to VS Code and we see it updates accordingly. So now we no longer see our node running and we no longer see our hello world topic or the services related to our node. Okay, we have covered a ton in this lecture, and we successfully got our publisher node to compile and run over ROS. But before I end this lecture, I want to stress the importance of sourcing your terminal to your ROS workspace. Right now, if I head over to my lower terminal, I can try run our publisher node using the same command that we see in the upper terminal. Here we see that our package is not found. That is because we did not source this second terminal to our workspace. So I can source the workspace again and rerun the command. And now we see it works without giving me that error. Now keep in mind, I'm currently in my workspace directory. If I'm in my home directory, I will need to be sure to include the full directory. So if I open a third terminal window, I'll go ahead and resize these a little bit. And I'll type in CD to go back to my home directory. So from the home directory, I would do source, workspaces, ROS2, install, setup.bash. You can also use the ~/ at the beginning right before workspaces, which will represent the home directory from anywhere you are located within your command prompt. So if I run that, I can go ahead and do our ROS2 run Udemy, and we're able to run this successfully as before. So this is the same way our bashrc file is set up to automatically source our ROS installation. The bashrc file is a hidden file in our home directory, so I can go ahead and open it like so. So this opens it in VS Code, and I will trust the file. And I will close our ROS2 status. I'll go ahead and consolidate this to one window. If we scroll down all the way to the bottom, we see all of the things which got added to our bashrc file when we were doing our ROS installations. If you want to have your workspace we are working with get sourced automatically every time we open a new terminal, you can just copy the command we ran earlier to the bottom of this file. And before I hit save, I just want to prove to you one more time that if I open a new terminal, which I'll go ahead and close these last two terminals, and I'll open a new terminal down here. And if I try to run ROS2 run Udemy ROS2 package publisher, right? It says package not found. And now if I go ahead and save the bashrc file with this new source command, go ahead and close this terminal, open a brand new one, run that same command, and we see it runs without any issue. That's because we are now automatically sourcing our workspace from our bashrc file. So I'll go ahead and stop this from running, and I'll actually go ahead and delete this from my bashrc file for now, because you will instead see me manually source my workspace every time I run anything. That way you can remember this concept, but feel free to keep it as to automatically source your workspace. So I'll just go ahead and save this and close it from our VS Code. All right, with that, you've learned how to compile and run our C++ nodes, as well as the importance of sourcing our workspace so our terminal is aware of our ROS files that are available. All right, in this lecture, we went over compiling our ROS C++ nodes. So the first thing we had to do was add dependencies to our package.xml file to let ROS know what we needed for our ROS package. So this included things like the ament cmake build tool dependency, as well as our ROS client libraries and the message library we were using. We also had to add these dependencies to our cmake list text file so the compiler knew how to utilize these dependencies, which we did using the find package function, followed by the name of these packages, and then the required keyword. Then to actually go ahead and add our C++ node executables, we used the add executable call, followed by the name of the executable we wanted, and where that source file was located. We then also called ament target dependencies so that we could tie our ROS dependencies to our node, such as our ROS client libraries and our standard messages package. Then we went ahead and installed these targets with our executable name into the lib folder of our project so that we could interact with our packages in the ROS2 command line interface tools whenever we sourced our workspace.